Hello and welcome. In the previous lesson, you learned about Swift variables and constants. You learned how to create some data and declare a variable or constant to keep track of it. And if you did the challenge, you also learned about math operations using variables. Well, in this lesson, you're going to learn how to organize and group together your code statements so that number one, all of the code statements that you've grouped together can work together for a common task. And number two, once your code is organized into groups, you can choose which group of code statements to run depending on what task you need to be done. These groups of code statements are known as functions in Swift. Alright, but before we dive in, just in case you're new here, my name is Chris and welcome to Code with Chris, the place to be if you want to learn how to make an app. Now, I have a quick question for you. Have you tried to learn Swift programming before? And if you have, how did that go? Let me know by leaving a quick comment below, and on your way down there, please give this video a thumbs up. It helps out the video more than you know, so thank you. Alright, now let's take a look at the view update lifecycle diagram from the previous lesson and see where functions might play a part in this lifecycle. Remember that when the user interacts with the UI, Swift code captures that event and reacts to it. Well, here we might have a couple of different functions depending on how the user interacts with our UI. For example, the user tapping a button might trigger the app to switch screens. In that case, maybe we'll run function A to perform that task. Or on the other hand, what if the user taps on an item to see more detail? Then in that case, we'll run function B to bring up the details screen. Now let's go over the code that performs the data retrieval. For example, we might have a function C that does the actual retrieval of the data, maybe the networking code. And it grabs the data and then gives it to function D as input. And the responsibility of this function might be to process that data and turn it into a format that our app can understand. So function D takes that data as input and it outputs the formatted data for our app. Now I could go on, but as you can see, functions are a basic component of Swift programming. It's everywhere. So now let's go and see how we can create our own functions. Alright, so here I have a brand new Xcode playground, and we're going to take a look at the function syntax. And just in case I haven't explained it yet, the word syntax is simply a word describing the structure or the grammar of the language. So, function syntax. To declare a new function, you start with the func keyword, F-U-N-C. So it's a funky function. And then you follow it by the name of the function, and then a set of parentheses or rounded brackets, and then a set of curly brackets. Inside the set of curly brackets, you put your code statements, anything you want to execute or run whenever we call this function. So let me just put some statements here. Let's say declare two constants like this, and then let's print a plus b. So if I run this right now and execute all these lines of code, nothing is going to happen. You don't see any output. And that's because we haven't actually called this function. In order to call and to execute this function, we just have to reference it by the function name. So that's my func followed by the pair parentheses. And that is how you execute all of the code in between here. So let's try this out. I'm going to stop executing and then run my playground again. And we get 30 as we expect. If I wanted to run those set of instructions again, then I can just simply call it again. And if I print it out, now it executes that code twice. Now I want to go back to that view update lifecycle diagram for just a second, because if you notice back in that data retrieval area, I said that we might have two functions C and functions D, where C would fetch the data and pass it into D as input parameters, so that function D can work with that data and format it how we need. So a function being able to accept data into it to work with it is a very powerful feature. Let's take a look at how we would declare a function that would accept some sort of input data. All right, so I'm going to erase these two lines and I'm going to modify my function here. Instead of declaring two constants A and B, I am going to specify that A and B have to be passed into the function. So the way we do that is through the use of function parameters. In between the two rounded brackets, that is where we would specify all of the parameters we want to be passed into this function. You can pass in multiple parameters, but actually let's just start with one. Let's just start with A. So first I would put the name of the parameter. So I would want that to be A. And then I would put colon specified by the data type that this parameter is. Since I expect it to be int, I'm going to declare this parameter as A followed by the data type int. And then I can erase this constant from here. As you can see, this is almost like a variable declaration or a constant declaration, except without the var and without the let. Here we're specifying that whenever this function is called, one int parameter needs to be passed in along with it. And it's going to be referenced by this parameter name, A, inside this function. So now you can see that nowhere did I declare a variable A or a constant A, but I can still put A as part of my equation, A plus B, because A is being passed in as a parameter. So let's take a look at what calling this function would look like now. I'm going to rely on autocomplete. So I'm going to type in myfun, and you can see as soon as I do that, it detects my function here. So I'm going to go ahead and click that, and you can see that now in the process of calling this function, I also have to pass in an integer piece of data. So I'm going to go ahead and pass in, let's pass in something different. Let's pass in 5. You can see here there indicates this is the parameter that I'm passing in. Let's go ahead, stop and execute, run my lines of code again. And this time the output is 25 because 5 was being passed into the function, plus 20 is 25. Now going back to the view update lifecycle diagram again, function D accepts input as a parameter, but it also returns output. So that is another very powerful feature of functions, being able to take in some input, work with that data, and provide some output back to the caller of the function. So let's take a look at our playground and see how we can specify that a function should return some data. So to modify this function to indicate that it will return some data, we go up here right after the rounded bracket for the parameter and just before the start of the curly brackets. In here, we write a dash followed by a greater than symbol, which makes sort of like an arrow, like output. And then we specify the data type of the output. So what I'm going to do is I'm going to output the sum of A and B instead of printing it out to the console. So I'm going to erase this line, and then I'm going to output an int. So that's where I specify that right after that dash greater than symbol. Now you can see that Xcode throws some errors now because in addition to specifying that your function returns an int, you actually have to return an int inside of the code statements. So as the last line of our code, we can use the return keyword, meaning that this is the data we're going to return from the function, and then we specify the int data that we want to return. So I'm going to return A plus B, and all is well. Now keep in mind that whatever the data type you specify up here in the function declaration, that is the data type that you have to return. If there's a mismatch, for example, if I specified that this function returns an int, but I go ahead and return a string, like a piece of text, you're going to see Xcode complain about that as well, because that is incorrect. So we're going to return A plus B, and we're going to return an int. So why don't we run our function now and see what happens? Nothing happens. Well, what's going on? I'm returning A plus B. So here's what's happening. Calling this function is returning that data, but I need to somehow reference and track that data, right? And that's what a variable is for. So I am going to declare a variable up here, var, let's declare a constant actually, since I'm not going to change this. Let my sum equals the result of that function. So you can understand this code statement, right? We're declaring a constant called mySum, and then we are calling this function on the same line that returns 25, and we're assigning 25 to mySum. So now I can print mySum, and let's double check that we get the output. There we go. Now, before we move on, there are two very important things that I want to mention. So this return statement actually ends the execution of that function. So once this return statement is run, execution returns out of that function. So any code statements that you put down here, like let's say I had return AB right there, and I printed A plus B right here, that print statement is not going to be run. See, code after return will never be executed. So that's just important to keep in mind, that when you write return and it executes that line of code, the execution stops and gets out of that function. Another thing that I wanted to mention is this return type. So earlier when I told you that declaring a function didn't have a return type like that, well, it actually did. It was just that the return type was void, and void means nothing. So let me do a basic demonstration. Actually, let me just declare another function down here. I'll just call this myfunc2. See, back then I told you this was a basic declaration of a function, but actually that was a shorthand. The full declaration actually has a return type of void like that if you're not going to return anything. But it's just that when you don't return anything, then you don't actually have to specify the return type of void. So I just thought I'd mention that so you know what that void keyword means. So if you see some function that has a return type of void, you know that that basically means that it's not returning anything. All right, so now let's reset a little bit. It's starting to get a little messy, so let's erase everything except our function right here. Now I want to show you how we can pass in multiple parameters. So instead of specifying B here, let's put B into the parameter listing here and have it be passed in instead. Okay, so let me erase this line of code so that we get B from up here. Well, how do we add another parameter to this one? What you do is simply put comma and then declare another parameter for your function. Easy, right? We're going to name this one B, followed by colon, and then the data type of B. That's going to be another integer. All right, so now let's take a look at how we call this function with two parameters. myfunc, you can see that here. Now you just specify. Oh, one quick thing is when you're calling functions, an easy way to just fill in the parameters in the list is by pressing tab. That just brings you over to the next parameter that you have to fill. So I'll put 2 and 3. Let's execute all of this code and we get a result. We get no result. Remember, I erased my line of code. So why don't we just print out the result instead of assigning it to a variable this time? So I'm going to go ahead and directly pass that function call into my print statement. That's going to print out the output of my function. Let's go ahead and run that code and we get 5. Now, obviously you can have more than 2 parameters. Just put a comma in between each parameter in your function. And another thing I want to mention that's pretty cool with parameters is that you can specify a default value for a parameter. So for example, for parameter B, I could make this an optional input data by specifying a default value for this parameter. If I do that, that means that when this function is called, passing in data for parameter B is going to be optional. Let's take a look at how this works. So after I specify the data type for my B parameter, I can put an equal sign and then I can give it a value. Let's say 0 is the default value. If B is not passed in, then B is just going to be 0. Now, let's erase my function call and let's try calling it again and take a look at what the autocomplete menu shows us. Here you can see that there are 2 different forms of my function call now. One is with parameters A and B, so I pass in both pieces of data, and one is just simply passing in parameter A. If I do that, B is just going to be 0, but if I pass in both of them, let's say I pass in 2 and 3 again, then B is going to be 3 instead of 0. So that's one way to make your parameters optional. Now I want to talk about argument labels. As you can imagine, the more parameters we have, the more confusing things are going to be in terms of these function calls, especially when it comes to parameter names like A and B. Well, sometimes A and B makes sense in the context of the code inside of the function, but to the caller of the function, A and B, they don't mean anything. So there's a special feature called argument labels, and let me show you what that looks like. So I'm going to declare a new function right here. I'm going to call it myfunc as well, and I am going to actually, you know what? I'm going to just copy this function and make a copy of it and show you how argument labels change it. So an argument label goes in front of each parameter. So each parameter can have its own argument label, and you're essentially just putting a name in front of that parameter. I'm going to call this first parameter, I'm going to give it an argument label called first number, and for my for the second parameter, I'm going to give it an argument label called second number. So that's literally all it is. An argument label is a name in front of the parameter name, separated by a space. Let's take a look at how this affects the function call. If I type in myfunc, you can see here I still have these first two ones, A and B, and that's from the first function up here. But look down here, I have first number and second number, and this corresponds to my second function right here, because the second number is still optional, right? Because I have this default value there. So if I call that one, my function call becomes this myfunc first number 1 and second number 3. However, internally, inside of that function, I'm still referencing those parameters using A and B. So argument labels, they're a way for you to distinguish the naming for a function call versus how it's referenced inside the code. Whereas if you omit the argument labels, like we've done up here, then the parameter names are used for both the function call and also the referencing of those parameters inside of the function. So hopefully you notice the difference here. One cool trick you can do with argument labels is if you don't want to show any text in your function call at all, you can use an underscore as your argument label. So if you do this, let's see what happens to your function call. So myfunc, you can see here, these two correspond to what I've done right here, using underscores for the argument labels. So if you use an underscore for an argument label, the function calls just become myfunc, and then the first piece of data, comma, second piece of data. There's no parameter names, there's no argument labels in your function call at all. So this makes things really succinct and really neat and tidy, but it also makes things more confusing if it's not clear what those parameters are supposed to be for. So there's a lot of versatility here. My personal preference is simply to do it this first way, and I don't usually specify any argument labels at all, and I simply use the parameter names. Okay, last thing, I promise, before we end off with functions, is I don't know if you've noticed, but we've declared two different functions here, both with the same function name. We can't do that with variables, right? If you try to declare variable A and then variable A again, then you're going to get an error on the second one, and Xcode is going to complain. You cannot redeclare variable A. For functions, things are a little bit different. Functions have what's called a function signature, and that is comprised of the function name, the parameter listing, and then followed by the return type. So let's type myfunc and take a look at what the autocomplete menu gives us. As you can see, all four of these variations have the same function name called myfunc, but because the parameter values, the argument labels, they're different, Xcode is able to discern and to know which function we're trying to call, right? So if I call this one and I don't specify any parameter names or any argument labels, it knows that I'm trying to call this second one right here, because this method call, this function call, I mean, it doesn't match this first one. Whereas if I do my func and I specify parameter labels A and B, then it definitely knows that I'm trying to call the first one, because this call, this parameter listing here, matches up here. Okay, so I promise you that we went a little deeper than you probably need to know right now by showing you all of these options and ways that functions can be flexible. As we code together more, you'll see me just using more basic forms of functions, but at least, hey, now you know a lot more, and I'm sure you can appreciate how powerful these functions are. All right, this lesson was pretty action-packed. Let's do a recap before we wrap up the lesson. First of all, you learned how to declare basic functions, and then you learned how to declare functions which accept input data as parameters. Furthermore, you learned how to declare a function with multiple parameters. And again, functions wouldn't nearly be as useful if it couldn't output data, right? You learned how to do that using return types and the return keyword. You also learned about argument labels. And finally, you learned about function signatures. Now, to really get the hang of functions and to reinforce your learning, make sure you do the quiz and challenge for this lesson. And don't forget, you have a Swift cheat sheet that you can get from the nav link at the top of your student dashboard and print it out and keep it handy. You don't need to memorize anything. To get all of these extra resources, just visit CodeWithChris.com and sign in or create your account and then enroll in the 14-day beginner challenge. If you like this video, please give it a thumbs up and don't forget to subscribe and to turn on bell notifications so you don't miss the next lesson. Did I mention how glad I am to have you here learning with me? Well, I am. You're making great progress, and in the next lesson, I'll show you how to organize your functions into structures. So, I'll see you there.